overview for my final year project at Sligo IT. The aim of this project was to set up a real-time telemetry based system as well as an SMS alarm system, as well as using data-driven techniques to provide a suggested optimized control set point to the plant operator based off a machine learning algorithm trained on historical data from this specific site. The on-site Raspberry Pi is connected to the local PLC, which pulls the instrumentation data from the process, then pushes it to the cloud. The Raspberry Pi in the office pulls this data into it and monitors the conditions to trigger alarms if need be. The 4 alarms that we will be triggering are a high chlorine alarm, a machine learning algorithm output greater than 5% outside of a tolerance, as well as a loss of heartbeat from the on-site Raspberry Pi and a loss of Ethernet connection between the local PLC and the on-site Raspberry Pi. The Android application then is used for the operator to view their plant data in real time as well as see the suggested set point from the machine learning algorithm. So we're just going to take a quick walk through the app showing the user registration and login functionality as well as viewing the site instrumentation data. So we're just going to go ahead and register a new user. And now when we click register user, her credentials will be pushed through to the database and then used for the login functionality. As you can see here, the user's information has been pushed through. So we will now go back and we will log in under this name. The user is then taken through where their email address is shown, name, their site and town plant name, and then the various instrumentation data that they need as well. Here we have our office Raspberry Pi setup. We have our Raspberry Pi microcontroller, our Arduino Nano, the 8-channel relay block that provides the interface between the Raspberry Pi and the Arduino. We have the SIM800C chip, which provides the text outs, and we have the serial interface between the Arduino and the SIM800C to push the AT commands to the SIM when required. Here we also have an LED to give an indication of when an SMS has been called. When an SMS is called, the LED will stay on steady until the AT commands have been pushed to the SIM800C. When this is done and this text message has been sent, the LED will blink to indicate that the function has been successful, and it goes back to waiting until the next relay output. Just to give a quick example of how this would work, I'm just going to trigger an alarm. The function has been called, and the message has been sent successfully. Now, we're just going to simulate some of the text out alarms that we can by manipulating some information within the database. So, as we go through this video, we will see that the site Raspberry Pi is turned off, so therefore its heartbeat is frozen. This will be being monitored by the Office Pi, and it will generate a loss of heartbeat alarm whenever the timer for this condition runs out. Now, first alarm that we're going to trigger is the chlorine high set point. As you can see, our high set point is set to 1.7, whereas our last read chlorine residual reading in the database is 1.44. So if we lower this high set point lower than the actual reading, we will generate a text out alarm for high chlorine condition. And we have that through. So now we will bring the set point back up above so that the text won't come through again on the next read cycle. Now, one of the other alarms was that if the model output is outside of a tolerance of plus or minus 5%, then a reference set point. So here we have our set point reference, which is set to 1.65, while our model is suggesting a set point of 1.66. This gives us a live percentage error of 1.11%. Now, if this percentage error goes outside plus or minus 5% of percentage error, then we will generate a text out alarm. So to do that, we will just manipulate the reference set point to push the percentage error greater than 5%, and that will then trigger an alarm for us. As you can see, our percentage error is now 34%. And we've got our alarm. Now we just wait for our loss of heartbeat to come through. And we have our loss of heartbeat text out. So these are the couple of text out alarms that we can simulate here from the office by changing around some information. The fourth and final alarm we will generate on site by disconnecting the Ethernet connection between the PLC and the Raspberry Pi to simulate a loss of data migration. So we're here on site now to test the final text out alarm, which is a disconnection from the local area network between the Raspberry Pi and the PLC. We have all systems are running at the minute, as we have both heartbeats from both Pis as well as variables being updated. So now we'll just disconnect the Ethernet connection and wait for a text. And there we have